Look at the center of our solar system. It is a chaotic storm of nuclear fusion, radiating incomprehensible energy out into the void. To actually harness that cosmic power here on Earth, we don't rely on rare space-age materials. We rely on quartz sand. It is literally one of the most common, unrefined substances on the planet. We expect a lot from that sand. A solar panel sits outside for over 25 years, tanking severe thermal stress through freezing winters and direct impacts from hail, all while perfectly executing subatomic physics without a single moving part. Bridging the gap between a pile of dirt and a reliable, weatherproof electrical grid requires a relentless manufacturing gauntlet that spans from the microscopic manipulation of atoms all the way up to heavy industrial assembly. The process starts by aggressively forcing the silicon out of the rock. The raw quartz is dumped into an enormous furnace and blasted at over 2,000 degrees Celsius to isolate the pure silicon. That molten liquid is then put through the Czochralski process, where a seed crystal is dipped in and slowly pulled upward, drawing the silicon into a massive, highly uniform cylindrical ingot. You can't put a solid block of crystal on a roof, so wire saws carefully slice the ingot into extremely fragile wafers. Each one is cut thinner than 200 micrometers. Looking at this cross-section of the bare silicon wafer, you can see how we turn an inert slice of rock into an electrical generator. Baked with phosphorus in a high-temperature furnace, this chemical doping creates a negative electrical charge across the top. When sunlight strikes this boundary, the p-n junction, photons knock electrons loose. Because of opposing charges, they're forced to flow in one direction, creating a usable electrical current. With the internal chemistry now capable of turning light into electricity, the silicon has become a functional solid-state generator, but it remains incredibly brittle. A single drop would shatter the internal structure, requiring a shift from microscopic physics to heavy-duty industrial shielding. The individual cells are fed into automated stringer machines, where robotic arms rapidly solder thin copper ribbons across them, connecting the cells in a series. There is zero margin for error here. The slightest microscopic deviation in alignment can disrupt the electrical current and ruin the output of the entire grid. To protect this delicate array, we arrange it into a precise lamination sandwich. In this exploded view, interconnected cells are placed between toughened front glass, 2 layers of EVA film, and a durable backsheet. Loaded into a machine, extreme heat and pressure permanently fuse the layers together, completely sealing out moisture and oxygen. This impermeable seal allows the internal circuitry to survive decades of environmental exposure while maintaining its electrical integrity. Before any panel leaves the factory floor, it has to survive a final series of relentless quality control tests, starting with electroluminescence testing. Taking an X-ray style view of the module, the EL machine penetrates the panel to reveal tiny, glowing internal microcracks inside the silicon. These are structural fractures that human eyes simply cannot detect. If it passes, it moves to the sun simulator for a flash test. The machine blasts the panel with intensely calibrated artificial sunlight to measure its exact electrical output against standard operating conditions. Then come the physical torture chambers. Test modules are subjected to brutal mechanical loads that simulate heavy snow buildup, intense humidity chambers, and even violent hail impact tests. Passing these tests certifies the module as a reliable 25-year infrastructure asset, capable of steady power generation through a quarter-century of weathering. The true marvel of this entire manufacturing sequence is its massive global scalability. These identical modules roll out of megafactories to supply sprawling, utility-scale power grids that stretch out to the horizon, but they are exactly the same components you can wire together for a simple DIY cabin. It is an entirely modular technology that integrates directly into our existing architecture, silently powering active urban environments. A modern solar panel is perfectly purified dirt, engineered at the subatomic level, and armored by heavy industry to sit quietly on a roof and catch the power of a star.